So this is how you do partial fractions. Now the idea here is to take a large and kind of ugly rational polynomial and split it into something that's smaller and easier to work with. So we do this with a method that I like to call the split and solve. So this part is just a split. You're going to take the denominator factored. So here we have x minus 3 times x plus 3, and you split it up with an unknown coefficient on top. So here we have a over x minus 3 plus b over x plus 3. Now, if you have something that's squared in the denominator, it's a little bit different. You have to do all powers of that factor. So here we have x squared times x minus 8. So over here we're going to have a over x squared plus b over x plus c over x minus 8. You have to count that power down to 0 every time. But you don't take the 0 because that's just a constant. Same thing here. We have x times x plus pi squared. So we have a over x plus b over x plus pi plus c over x plus pi squared. And x cubed, an example of higher powers, a over x plus b over x squared plus c over x cubed. You just got all the powers of x there. Now, what if you have a denominator that can't be factored? Then it's a little bit different. Here we have x times x squared plus 1. And over here we have a over x plus bx plus c over x squared plus 1. So you want to take the order of this term here and go one less and put it in a generic form. So we have an x squared here. So the generic form of x squared would be ax squared plus bx plus c. We're going one less, so just the bx plus c is there. You had an x cubed here, you would put ax squared plus bx plus c on top. And here's another example of that same thing. We have x squared plus 1 and x squared plus 3. So we end up with ax plus b over x squared plus 1, cx plus d over x squared plus 3. Doesn't matter what letters you use up there, we're going to solve for them later. A little note here. If you have x squared minus a number, don't get fooled into writing it this way. You can always factor those. Here x squared minus 3 is x plus square root of 3 times x minus square root of 3. So here's an example that I'll work through. This is x plus 2 over x times x plus 1 squared. We've split that into a over x plus b over x plus 1 plus c over x plus 1 squared. Now what we want to do here is solve it. So we want to make this portion equal to this portion. And to do that we want to put it in a common denominator. So here to get a over x times x plus 1 squared, we have to multiply by x plus 1 squared. And you do the same here, multiply by x times x plus 1. Here you just multiply by x. So now we have equivalent statements here with the common denominators. So the numerators must be equal. Now from here there's two methods. Method 1 here you can use all the time. So I recommend you memorize this one. Method 2, just sometimes in some situations it's a little bit easier, but it doesn't always work. So method 1 is the best here. We're just going to take that top line, x plus 2 equals a times x plus 1 squared plus b times x plus 1 plus cx. And now what we're going to do is we're just going to choose values of x and solve for these coefficients, or these constants, sorry. You want to choose numbers that will make some of these terms go to 0. That's the easiest way to do it. So here we have x equals 0. So that's a 0, so on the left hand side we have 2. The 0 makes this term go to 0, and this term go to 0, and this term is just 1a. So we're left with 2 equals a, we've already solved a. Next up, x equals negative 1, that'll make all of these terms go to 0. So you're left with, over here, negative 1 plus 2 is 1, and negative 1 times c is negative c, so we have c equals negative 1. Last one, let's use x equals 1. So 1 plus 2 is 3. 2 squared is 4a. 1 times 2 is 2b plus c. And now we already know what a and c are, so we can just put those in there and solve for b. We get b equals -2. So now we've solved all of the constants. We can put them into our form there, and we've solved the question here. X plus 2 over x plus 1 squared, x times x plus 1 squared, equals 2 over x minus 2 over x plus 1 minus 1 over x plus 1 squared. So now let's have a look at method 2. So as I said before, method 2 doesn't work on everything. Cases where it doesn't work are these cases right here and here where you don't have a power 1 in the denominator, so don't use it on those. Really, this one, sometimes depending on the question, it's just a little bit easier to do it this way than the other way. We'll show you how it works here. So first thing we're going to do, we're just going to pull out our powers of x out of this equation. So for x squared, here x plus 1 squared, that's going to give us an ax squared, so there's a. Here x times x plus 1, that'll give you a bx squared, so we put a b there. Nothing for c. X's, everything gives you an x. There's two a's there, it'll be 1b, 1c, and the only constant here will be on the end of this term, it'll be 1a. So now that we've solved this, it's in the same form as the left side here, so the coefficients must be equal. So we can just write out equations there. So coefficients here for x squared are 0. Oh, sorry, this isn't that. This is for the constant term. So the constant term on the left side is 2, on the right side it's a. So we know a equals 2. Next up here, this is the coefficients for the x squared. On the left side here we don't have an x squared, so it's 0. On the right side we have a plus b. We already know a, it's 2, so we can solve b as -2. And now for the x, on the left side here we have 1x, so there's 1. On the right side, 2a plus b plus c. And we know a and b, sub those in, solve for c. c equals -1, and we've got the same answer that we had before. That's all there is to it.